Alright, in this brief video I'm going to have a quick look at the rules for differentiation and also have a look at a quick example of how we can apply this. So, the first one, for any equation with a power, we can differentiate it. Now you might have noticed in the video about the differentiating by first principles that the power got moved down to the front and then we lowered the power by 1. So we're going to use that same process here. So we move the power to the front, so we'll say f dash x is equal to, so it's nx to the power of, and lower the power by 1, so it becomes n minus 1. And that's it. The next rule for f of x equals g of x plus or minus h of x. This is basically just for an addition of two different functions. We just differentiate each of them individually. So it becomes f dash x equals g dash x plus or minus h dash x. Okay. For the next one, this is a constant multiple of g of x. So in this case, the constant just stays there and we differentiate everything else around it. And the last one, if f of x is a constant, then the derivative of that constant is going to be 0. Okay. Now there's a good reason for that. I'll show you that just over here. So if f of x is equal to c, we could write that as cx to the power of 0. And applying the rule here, we move the power down to the front and decrease the power by 1, so f dash x would become c times 0 times x to the power of negative 1. But because it's all being multiplied by 0, it's just equal to 0. And the thing is that we're never going to be able to dig ourselves out of this because we'll keep on multiplying 0 by something. So that's the reason that happens. So next, find the derivative of this, hence find f dash 2. Right. So what I'm going to do is I'm going to say that f dash x. Now we're going to be combining some of the rules, so you can see that we have a sum or difference of our functions. We also have a constant term involved. So we're going to move the power down to the front, so the 2 from here goes down with this 2 and it becomes 4. They get multiplied. Okay, it's x to the power of 1. I don't need to write it, but I will in this first instance. Minus the 3 moves down the front and power gets decreased by 1, so it becomes power of 2, and the term that has the 4 just disappears because it has become 0. I'll actually write that though, so plus 0. So now to simplify this, it's just 4x minus 3x squared. Okay, the last part of that question is to find f dash 2. So f dash 2 is equal to 4 times 2. We're subbing in 2 wherever we see the letter x, minus 3 times 2 squared. So that's going to be 8 minus 12, which is negative 4. What this means is that the gradient of this equation at x equals 2 is negative 4, which is quite nice. Just something else that I will mention while I am here is we can use something called Leibniz notation. So Leibniz was one of the mathematicians who is sort of credited with discovering calculus along with Newton. And basically he used slightly different notation. So even instead of having f dash x, Leibniz notation would be written as dy dx. Okay, we say just dy dx, it's not dy over dx or anything like that, it's just dy dx. And they both mean the same thing, so if you encounter them, just be aware that that's what it means. Anyway, leave it there.